Hello Legacy students, Marsh here. So today we're going to find slant asymptotes. This is the second day on graphing rational functions. You're going to want your notes today. You may want a calculator just to do some simple math, and then you're also definitely going to want some graph paper today. So, finding slant asymptotes. Exactly what are they? Well, they occur when the degree of your numerator is exactly 1 bigger than the degree of the denominator. So on Schradasy, this is what's known as top-heavy. In this case, you're not going to get a horizontal asymptote. You're actually going to get a slanted line, like a linear equation, kind of like you've graphed before. To find the equation of your asymptote, we need to use long division. Reason why we learned it earlier. So we're going to divide the numerator by the denominator. So let's do a little bit of test here. Can we find a slant asymptote? So they tell me that I need to divide x squared minus 6x plus 7 by x plus 5. So I'm going to set up my division. So x plus 5 divided by x squared minus 6x plus 7. So then, remember guys, how do we do this long division? Let's remind ourselves. We needed to ask ourselves, something times x had to give us x squared. Well, that's x, right? So then we multiplied x times x, we got x squared. X times 5 is 5x. And then we changed the signs. Because remember, we're subtracting the quantity, so we had to change the signs. So I got x squared minus x squared. Those guys cancel off. Negative 6x minus 5x. That is negative 11x. Drop the 7 down. And then we started the process yet again. Something times x gives me negative 11x. That would be negative 11. So negative 11 times x is negative 11x. Negative 11 times 5 is negative 55. Don't forget to swap our signs, so that way these guys cancel off. So I got 7 plus 55, that is 62. So that's my remainder. Now remember guys, last time we did plus 62 over x plus 5. That is not what you need. When you're doing your slant asymptotes, the remainder does not matter. This right here is your slant asymptote. So I know my slant asymptote has an equation of y equals x minus 11. And you would graph that on a graph. You would start at negative 11 on your y-axis, go up 1 to the right 1, and then that would be your line that you would draw. Let's find another one. So I'm going to divide 2x plus 6 into 3x squared plus x minus 2. Alright, so something times 2x needs to give me 3x squared. Hold up. Something times 2 needs to give me 3? What? That's weird. Let's think that off to the side here. Let's do a little brainstorming session. So something x times 2 has to give me 3. If I solve for that something, I would get 3 halves, right? So that tells me that 3 halves x times 2x will give me 3x squared. I know that one's a little difficult. Just keep that in mind, that if they are kind of an odd one, you can have a fraction there. That's fine. So I'm going to have 3 halves x times 2x. That is 3x squared. 3 halves x times 6. 18 over 2. 9x. Okay, change my signs. Those guys are on. Negative 8x minus 2, because I got to drop the negative 2. So something times 2x needs to give me negative 8x. Something times 2. That would be negative 4. Change signs, and I got 22. So, remember guys, I don't care about the remainder. All I care about is the equation of our slant asymptote. So y equals 3 halves x minus 4 is the equation of my slant asymptote. So let's actually try with an equation now. Like, let's try to see if we can figure this one out. So we're going to start with Schradisy. So I'm going to start with an S. We got to simplify, remember, so we're going to factor the top. So two numbers that multiply to give me -3, but add together to give me -2. -3 and a +1, I think we'll do that. Okay, now we look for our holes. Holes, remember, are the people that cross off, which in this case, nobody. Womp womp. That's okay. Roots are your answers to the tops, your x-intercepts. So I'm going to set x minus 3 equal to 0 and x plus 1 equal to 0. So I know that x can either be 3 or x can be -1. So in this case, my two roots are at 3, 0 and -1, 0. So let's put the dots on our graph here. There we go. Okay, my asymptote is the answers to the bottom. So I'm going to set the denominator equal to 0. So now x can be 2. So that's an asymptote, vertical asymptote at x equals 2. So I'm going to draw my dashed line there. There we go. Okay. The t's. So tangencies, we have duplicates in the top. Notice no duplicates, so no tangency. Do I have any togetherness? Is there duplicates on the bottom? No, so we don't have together. So that means that at the asymptote here, they're going to have to go in different directions. Good thing to know. Let's check our end behavior. So end behavior, remember, there's top heavy, equal, and bottom heavy. So I'm going to want to look at the original, okay, because this I didn't simplify. I have an x squared over an x, which to me means top heavy. I have more in the numerator, and it's 1 more to be exact. So I have to do long division. So let's long divide here. So something times x needs to give me x squared, be an x. So let's multiply here. Boop, boop, boop. And, oh, everything's canceling out. Get -3 there. Well, that's got to be the equation. So the equation of my slant asymptote is y equals x. Now, be careful, graphing him. He starts at 0, 0, right? And then he goes up 1 over 1 a whole bunch. So I'm going to make a dashed line for him because he is an asymptote. So I'm going to do a dashed line for him. Now notice how he's slanty. That's why they're called a slant asymptote. So what this tells me is that the ends of my graphs, they're going to get really close to this line, but they're not going to cross it on the edges. Now let's do our C, my crosses. I'm going to move over here. So crosses, careful. You need to set it equal to your slant asymptote. So I'm going to set x over 1 equal to my function. There we go. Cross multiply here, so I get x squared minus 2x equals x squared minus 2x minus 3. Well, if I subtract and add this, it's going to cancel out. So I'm going to get 0 equals -3. So this tells me I'm not going to cross in the middle. Good thing. And yes, guys, they will one time. I guarantee you it's going to cross. We just haven't hit a problem like that yet. Let's try a y. Let's do our y-intercept. So let's plug a 0 in. All right. 0 minus 0. That's 0 minus 3. It's -3 over -2. aka my y-intercept is 0, 1.5, roughly. Which is 1.5 about right here. There we go. Alright. Gotta do some graphing. Well, we did talk about how on the left side of the graph we have to kind of follow this line, right? So it's going to kind of follow the line. I have to hit through -1, and I have to hit through that 3/2 dot. And then I'm going to kind of hug the asymptote going up. So that's one boomerang. Let me do my other boomerang in a different color here. So the other boomerang, notice guys, it can't go through here because we said we can't go through the slant asymptote. That was our crosses. We said we cannot cross. So this guy, he's going to go down, plus we're not together, so I can't go up. I got to go down because this side's going up, this side's got to go down. And then we're going to follow the slant asymptote. So this red dash, this red boomerang, and the blue boomerang would be my answer to this particular graph. Let's find the domain now. Notice, guys, I can't cross 2 for the x values, so that is my domain. Can't include 2. Range, however, notice I am getting all the negative values, right? Not every single negative value, and every single positive value. So this range is -infinity to infinity. Now, for this problem, guys, just so this video isn't too long, what I'm going to want you to do is complete this one on your own. So you're going to want to pause right now, stop. You want to complete the strategy, try to graph the best you can, and then you should unpause me and I will show you the graph. So you should have already drawn your graph. Check it with mine here. So I got my black asymptotes, a slant and a vertical, and then I also have my green boomerangs. Now notice this one, guys, it is kind of a little strange. He does kind of go like whoop, kind of turn around, if you want to consider it that way. The domain is even a little stranger on this one. So domain, you can only not include -1. So from -infinity to -1, and then -1 to infinity. Now, range. Range is really weird because I really don't know what this dot is. Could you plug it into like Desmos and find that? Yes, but we're going to kind of estimate. So this guy, it looks like it's like 5.5, -5.5. So my range is from -infinity to -5.5, -5.5. And then I pick up the trail again at about like -0.5. to infinity. Now, are those exact numbers? No. What you could do is you can make sure that as long as your graph matches your domain and range, because I'm looking at your graph to match your domain and range, due to the fact of, in case, especially with range, in case you have drawn the graph a little differently compared to like what I would have done. Okay? And that's the end of this video. See you later, Sabers.